So I wanted to start today with once more revisiting that program from episode 0 where we're adding up numbers from 0 to n. And through a different project I was working on that maybe we'll take a look at in this episode, maybe the next episode, I'm starting to wrap my head around the sort of the paradigm of thinking about the programming problems that I have, not as business logic or not as database lookups or whatever, any other paradigm, but thinking them as data transformations, which I think is a common way for functional programming languages to present problems and to think about problems. And a lot of problems can be reduced to that, and I think it helps you figure out how to leverage the capabilities of these languages to solve your problems. Which really in Elixir brings us to two really key libraries, and one is Enum and the other is Stream, and they're similar but different. And I would definitely start with Enum. So Enum gives you a way to deal with lists and do things with lists. It can deal with other kinds of collections as well, and I think actually it can deal with dictionaries, hashtags, and some other things as well. But the point is, it gives you a set of common functions that you would want to perform on a list. So the three that I use all the time are filter. So filter, you take a collection, you want to run it through some function, and then the elements for which that function returns true gets returned in the output. So you could say pass in the numbers 1 to 10, you could filter out all the ones that are odd, and you'd be left with the even numbers. So that's a filter. A map is basically a manipulation of a collection where you start with a collection and you want to end with a collection, but a different collection. And then reduce is the case where you start with a collection and you want to end up with a single result. So if you're doing things like summing numbers, that would be a reduction. If you had a list and you wanted to double all the numbers in the list, that would be a map. So enumerations deal with lists that are already lists, and Stream is the other really important, I think, library. And Stream basically has most of the functions that Enum does, but it does this through a sort of lazy evaluation. So whereas Enum needs to have the list fully created before it can do its thing, Stream will sort of lazily evaluate the next element from a list. So if you were, say, reading a file line by line, that would be a stream. Let's say if you were taking readings from some sort of external sensor, a humidity monitor or whatever, that would be a stream, and that you would just, when you need it, you go hit the device, get the next value, as opposed to waiting for all of them to exist up front. And so this brought me back to the original problem of summing numbers from 1 to n. And here you can see the output. I won't make you sit here through this 40-second plus run of the program. Method 1, you'll recall, was the non-tail call optimized version of the summing function. Method 2 is the tail call optimized version. And then method 3 and method 4 are two new versions we'll see that are leveraging Enum in two different ways. And you'll see that both of them are remarkably similar in the runtimes, and also remarkably slower than the tail call optimized version. So we'll go in here and take a look at what method 3 and method 4 are doing. So method 3 creates a list from 1 to limit, in our case 1,000,000, passes that list into the enumeration reduce function. So again, if you have a list and you want to come up with a single value, you want reduce. So reduce takes a list from 1 to 1,000,000. This next parameter 0 is the initial value of the accumulator. We want to start it out at 0. The function passes in the current value from the list as x, and then the current value of the accumulator, which for the first call would be 0. And then all we do is we take x and we add it to the accumulator, and that's it. And that's what reduce does. So it's the same functionality, it gets the same answer, albeit about 5 times more slowly than the tail call optimized version. And then in method 4, I just went ahead and used the enum sum function, which is just sitting right there. Why not give it a shot? And based on the similarity in the numbers, I'm assuming that enum is just basically doing exactly what the reduce function does. So the next question in my mind was, if we're using those built-ins and they're built in, these libraries that are obviously focused on doing this kind of work, why are they so much slower? And the reason I came up with is actually the fact that the list from 1 to 1,000,000 is getting created before enum can do its thing. So I poked around a little bit in the stream library to see if there's an easy way to mimic this using a stream, and I didn't immediately see one. So maybe there is, and I just didn't notice it. But the point is, these libraries, stream and Enum, are super important. Tons of capability in here, and great methods for you to check, or great functions, great libraries for you to check around, poke around a little bit in.